So let y be the number of occurrences of a random variable y in Bernoulli trials with success probability p, and p lies between 0 and 1. So one can very easy to write the distribution, which is probability of y is equal to y, or y given the parameter n comma p is same as ncy p raised to y 1 minus p 1 minus p raised to n minus y, which is this, right? So this is your usual binomial distribution. So if you just get the mean and variance of this, so expected value of y is equal to y given n comma p, which is nothing but your mean, okay, which is your np. This is the usual way we can say expected value of y also, or variance will be your np 1 minus p. Okay. Now using the principle of Bayesian inference, let us suppose that p, which is the probability, right? So usually in your binomial distribution, this p is a constant, okay? P is a constant in each trial, but assume that now p is a random variable. P is your random variable, okay? And that follows a beta distribution. That follows a beta distribution with parameter a and b, or you can consider alpha and beta, whatever you want to compare. Okay. For a being, you can consider a and b. You can change later on a and b. Okay. So if you know the p is a random variable which follows the beta distribution, so one can consider their distribution p of a comma b, which is same as 1 upon beta a comma b, p raised to a minus 1, 1 minus p raised to b minus 1. A is positive, b is positive, and p lies between 0 and 1. Right? I'm sure you have done this also previously. Okay. So using the concept of Bayesian, one can get the distribution of, or probability density function of y is equal to y given with the parameter a and b, which is same as integration over the range of 0 to 1 into probability of y is equal to y given n comma p into your PDF of. So this is your prior distribution, right? This is your distribution prior data. This is your distribution which is given. This is your prior distribution, right? Based on this is your posterior distribution, which you have studied in terms of unit 1 and 2. Okay. So when you just simplify this, okay, substituting everything, so this distribution is ncy, which is constant. I'm skipping few terms here, since I'm not writing each and every steps here. We can just work on that. 0 to 1. So what is the next step? You can substitute this PDF and this PDF here. okay, and get it simplified. So I'm just collecting the terms. So we have p raised to y here, p raised to a plus 1 is here. So we just merge it. So this is y plus a minus 1. Similarly, 1 minus pk term may we have the data. So which is n minus yeah, I think I just got some technical issue. Okay. So with this, you can get the distribution of your 1 upon beta a comma b, and this is your beta with y plus a n minus y plus b. And this distribution is known as beta binomial distribution with parameter n comma a comma b. Can you understand this? Please go through. This is you have, I'm sure with this you have already done this derivation in your unit 1 and 2. Yes, do you have it? Have you done it, this particular derivation? But the name is now little different. Entire thing is it is same. किया है क्या? Those who have attended the class and all, have you got
Yes,
such a
sir.
page? So any query here till here? Anyone? So go to chat box, write down y, so that we can go ahead. Go to chat box, write down y, so that we can go ahead. Fine. Let's go ahead. Now, once you know the distribution of any PDF, one can get their mean, one can get their variance, right? One can get their mean, one can get their variance. So which is very easy. So it is expected value of your y given n comma a comma b, which is simply, you can say expected. So you can take a conditional expectation. So it is expected value of y given n comma a comma b comma p. So this would be similarly n into expected value of p given a comma b, is simply n into what is expected value of p a comma b, p a comma b, p given a comma b. So p ka, what is the p ka, what is the distribution of p? P is beta binomial. Sorry, p is a beta distribution. So what is the mean? So it is a
A
upon,
upon A plus B.
correct. So you will be get a upon a plus b. Similarly, you can get the variance also. So variance I'm just writing directly n comma a comma b, which is same as, you can use the formula for expected of variance of. So here you have to use the conditional mean and conditional variance concepts. Okay, and using that one can get the mean and variance for beta binomial. So you can just write down this, whatever answer is there. I'm just writing the answers at the last here. So this would be your N A B. Just do the little blank part. Okay, so this is your variance for this particular distribution. But if you just observe these two distributions, if this particular proportion, that is a upon a plus b, if we just consider this particular proportion will be assume it is theta, and so this particular expected expected value of y will be your n theta, or you can assume p. Okay, so np, and similarly you have to assume here also some quantity a upon a plus b, some other quantity. So this is basically called as, this technique is basically called as reparameterization. So I am just changing my original parameter to some other parameter to get this, because we have to estimate this parameter, right? Once you have defined the distribution, once you have obtained the posterior distribution, the next task is that we have to estimate this parameter. So how we can get this parameter? So for that we have to, because it is not an easy task to compute these parameters. So what you have to do, you have to use the parameterization. So you can use the reparameterization. So, and use full parameterization of this model. Consider a is equal to theta tau inverse, that means theta upon tau, and b is nothing but 1 minus theta upon tau inverse. Okay, so here obvious that tau is positive and theta lies between 0 and 1. Okay, so what is your expected value of y in this case? So y given n comma tau will be n theta simply, and variance become y given n comma theta tau become n theta 1 minus theta in the bracket 1 plus n minus 1 tau upon 1 plus tau. Okay, this you will be get definitely when you just substituting this a and b value will be in the mean, in the variance. So in this case it is very easy. So a is this 1 plus tau inverse, and if you just merge this plus this, so theta tau get cancelled, you're left with only tau, correct, in denominator, and in numerator we have theta tau inverse, and denominator we have tau, so that will get cancelled, so we're left with only theta. Okay, so just substitute this a and b value in the mean and variance. So just substituting the mean and variance, the mean, conditional mean and variance becomes simplified to this version. Now what happens if I'm just substituting this tau becomes 0? That means if there is a here this tau parameter, the parameter tau is called as over dispersion. Okay, over dispersion parameter. And if this tau becomes 0, so what you can conclude? So variance of y under n comma theta comma tau become n theta 1 minus theta, which is same as your variance of y given n comma theta. Check karo, please cross check that, is it right? Or are you getting something here or not? That is the big question, because that is the first question actually, I tell you.
So can you explain what you just said again?
say we got the variance of, this is a conditional variance, right? So conditional variance is coming this n theta 1 minus theta 1 plus n minus 1 tau divided by 1 plus tau, which is just substituting a and b will be here, you will get this variance. Okay, now this tau is known as the over dispersion parameter. So what over dispersion parameter says? Over dispersion parameter means that you have suppose you have two model A, model B. Model A having some variance, model B having some variance, but the model 2 variance is higher than the model 1 variance. So I can suggest that, I can say that model 2 will be the more dispersed as compared to the model 1. So here what I'm trying to say, if my tau is 0, okay, if my this parameter is 0, that means, so if it is 0, then obvious this term goes away, we'll get only 1, which is same as n theta 1 minus theta. But this is what actually, this is nothing but what? This is your variance of y given n comma theta, which is the actual your variance of, actually your variance of the original, means I can say binomial distribution. Because what is a binomial distribution? It is ncy theta raised to y 1 minus theta raised to n minus y. So if this tau becomes 0, so variance of your beta distribution, variance of your beta binomial distribution is same as the variance of your binomial distribution. So there will be no change in the distributions of your binomial. So variance are same. Okay, so that means that is the variance is equivalent to, that is variance is equivalent to the variance of a random variable that follows a binomial distribution. And the probability, so you can have the probability mass function also, you can change with that, that is not a big deal. Okay, so the probability mass function so the probability mass function is given by ncy beta y plus, instead of now a, here we have a, right? So a become theta upon tau. So this is theta upon tau comma n minus y plus 1 minus theta upon tau, whole thing divided by beta theta upon tau 1 minus theta upon tau. Okay, now you can express in terms of gamma also, ncy, it's a gamma y plus theta upon tau, so gamma a gamma b upon gamma a plus b, so n minus y 1 minus theta upon tau, whole thing divided by gamma of this plus this, right? So a by theta by tau, theta will get cancelled, y get cancelled, so you're left with here n plus 1 upon tau. So it's n plus 1 upon tau. I think it's clear. This will be the denominator. N2, have to express this in terms of tau, gamma. So it is theta upon tau into 1 minus theta upon tau into divided by, so that goes in numerator. So it is going to be this plus this. So theta upon tau, theta get cancelled. So we're left with the gamma 1 upon tau. Okay. So this is, I just skip one step so that I hope it is clear. It's just reducing the steps. Okay. Now there is a one standard result. For given C positive, D positive, and K integer value, and greater than 0 is valid relation we have. Valid relation is valid the relation. Product running from 0 to K, D plus JC is same as C power 2 K plus 1 divided by K plus D upon C plus 1 divided by gamma D upon C. So means if we have this expression gamma K plus D upon C plus 1 upon gamma D plus C into multiply this constant, I can express this entire gamma function in terms of product. Okay. So I'm just trying to write down this particular gamma product in terms of product. So how you can do this? How one can able to express that function? Means using this result, one can express this particular gamma function in terms of product. Will it be possible here? So this expression will be, now look at here, we have the K plus D upon C plus 1 upon gamma D upon C. Okay. So can you take this term with this term, and will you try to express in terms of this? Because here also we have D upon C, so here we have also theta upon tau. So we try to collect these two terms. Similarly, we try to collect these two terms, and we try to collect these two terms. Okay, like that we can express it. So how it works? So NCY will be as it is. Okay. Collect this term with this term, and look at, I'm writing this is same as product of j is running from 0 to y minus 1, right? Because this is the k. Now here we have y. So we have to write y minus 1. Now y minus 1, because there is a k plus 1 term. Here we have a k. So we have written a k plus 1 term. But here we have y. So have to take one reduce. So y minus 1. This is same as product of this. And this is d and c. You can look at d and c. So d and c. So d will be theta. C will be your tau. So this is theta plus j time tau. Can you understand this? Into similarly product j is earning from, you can just look at the next product. You can take these two terms. You can consider this term. You consider this term. Okay. Just work on this. So again here, this is the C, this is D, this is C. So we can work according to that. So this is 1 minus theta plus j tau n minus y minus 1 whole thing divided by, we have denominator mein this term because it will take reciprocal of this. So this is same as product j is running from 0 to n minus 1. Again here we have a C, we have a D, sorry, we have a D is 1, C is tau, so 1 plus j tau. So one can express this entire gamma function in terms of product also. Okay, this is another way of representing the your distribution. So this is the distribution of your y given n comma theta comma tau. Are you getting something here? कुछ समझ में आ रहा है इसमें? So what happened if you just substituting tau is 0 here, for example? So if you're substituting tau is 0, तो क्या मिल जाएगा आपको? NCY product j is running from 0 to y, so it is theta into products running from 0 to n minus y minus 1, 1 minus theta divided by tau is 0, so it is product j is running from 0 to n minus 1 of 1. क्या मिल रहा है? चेक करो. So it is independent. So it is theta raised to y minus 1. This is 1 minus theta raised to n minus y minus 1. What about this term? One, na? So we got, can you tell me, this is your binomial distribution with n comma theta. And what is your theta here? Your theta is nothing but here a upon a plus b, which is your parameter of your beta distribution. Can you understand little here?
Yes.
Because so the next time we will do the estimation of this parameter, which is usually we can use a method of moments and method of MLA. Okay, so I'm just touching this topic because for binomial, for Poisson, for geometric, hypergeometry, you have already done MLA, MMLA, everything, like ME, everything you have done it. Okay, but there the estimation was easy. Like you have started, like might be you have done it for the gamma distribution. So in gamma distribution, the estimation is not easy. So you are using some iterative procedure and you are estimating the parameters and all. Getting the point? So similar iterative procedure you have to use for this distribution also, because the parameter is not easy to estimate. You cannot estimate directly the parameter here, theta and tau. Okay, so we have to use some other method, which method is known as Newton-Raphson method, is widely used to estimate the parameter. Okay, so next class we will discuss the estimation method and how the estimation part done, and then